let's dive in. I'm going to open up my VS Code here. Alrighty, so you can see right here, I've got my, I'm going to make this window a little bit bigger. So I've got my VS Code. I've already got this project cloned into my VS Code editor here. You can see it is a Ruby on Rails project, version 6 here. So some of the requirements, if you're going to run this locally, we're actually not going to use Docker for this. So in the README, there'll be some details around how you'll need Ruby, you'll need MySQL, Postgres, various databases to actually run this. You only really need those if you're running it at, like maybe on a server somewhere. For our local purposes, we'll just be using SQLite. It just simplifies just getting this running in general by removing some of that complexity. There is a Docker file within here. So if you're comfortable with Docker, you could just launch this whole thing in a container if you wanted to play around with it. You could always obviously deploy that container elsewhere too if you wanted to play around with it. But we're just going to go ahead and follow these steps here for the most part to get everything installed and get our project going. So I'm going to open up my my command terminal down here. And you can do that again if you're kind of new to the VS Code world. Again, I'm on a Mac, so your Windows keys will be a little bit different, but it's the Control tilde key that opens this up. There's also in the top kind of menu bar, you can launch the terminal from up there as well. So the first thing we're going to do is I've already got a Ruby version here. That's kind of one of the main requirements. Like I said, we're not going to need SQL or a database for this because we'll use SQLite, but we will run the bundle install command here. And I'm just going to copy and paste. So I've already ran this command before. This is kind of like we're going to pull the fully baked cake out of the oven here, just so you don't have to wait through all these gem installs. If you do get an error, you'll have to have bundler install. There's some commands that will continue it on. But as long as this command completes successfully, we'll have all our gems that we need to run this application. And we can follow on to the next step, which is creating the SQLite database that we're going to use to actually run this application. So you'll see a couple of new databases get created, one for each of these environments. If you do run into any issues, I did notice that, at least for my M1 MacBook, there's a couple of gems that needed to be updated. It might be fine now because I've actually committed those changes to the gem file, but if any of these commands do give you a problem, these two commands right in this part of the README should resolve that for you. And that's really should be it. At this point now, I can run the Rails server and this will refresh and we've got our login page, and I can click on the sign up button. It'll take me to a sign up page. I could log in and do some playing around with this, but mainly just want to make sure that we can actually load the page. So this is, if you've made it this far, then really everything else should work pretty seamlessly here. And in the log, in the terminal below, you'll actually see the full debug log happening as we kind of navigate this application. So that's again another way that you know that everything's working and we're ready to continue from here. So the next thing we're going to do is I want to run all of the tests that we have here, and just to mainly give you an example of if you wanted to play around and hack on this project some more, and you wanted to find and fix some of these vulnerabilities on your own, these tests are a great way for you to learn how to do that. I'm going to actually run a larger suite. There's some commands down here that you'll see that you can run the Rails training command that will kick off all of these tests. But what we're going to do is actually run these tests with the Rails maintainer environment variable. And this essentially does kind of an inverse of these tests. The idea here is that now all of these tests will actually pass, or largely they will not fail. If you ran this test suite without this environment variable, all of the tests would pass. And that's what I was saying before. I mentioned that the idea is you go and fix these issues and then the tests pass after. And we'll show you an example of that because we're gonna find and fix one of these issues in this project along the way. So the main thing is we just want to make sure that there's no failures. You'll see some of these errors kick off there. This is just related to the tests actually running from here. So no issue there. But again, mainly we just want to make sure, can we run the tests? Because this is going to be how AppMap actually generates the maps. How it sees the code running is via either these tests or when we start interacting with the application, which will do both of those things. So from here, now I want to install AppMap into my code editor into this project. And to do that, if you're in VS Code, you can go to the extensions page here, and you can just search for AppMap. It'll show up in your list. I've already got AppMap installed, so I don't need to install it, but there'll just be a little install button here that will let this add it to your VS Code extension. And you'll actually see it show up in your left-hand bar so that it's ready to go and ready for you to start getting it installed in your project. So when we get AppMap installed into here, there's a couple of ways to install it. We can click on this button, which will just kick off our automated installer. This is what I'm going to do here to show you how that process works. But you could also just, again, add the library right to your gem file as well. Most importantly, making sure it's the first gem listed, because if we as an AppMap are loaded first in the gem list, then we're going to see all the other gems executing after the fact. So I'm just going to take the defaults for the installer. And again, what this is doing is adding me to my gem file. It's doing a bundle install to make sure that it works. It's dropping a configuration file, a default configuration file in place. And then at the end of this, it's going to prompt me to commit these to this repository. And now this is really helpful. So if I'm collaborating with other engineers on my team, I can commit all these files to my project. And so when I push these up, when other users clone this project and want to work on it, they don't have to install AppMap. It's all right there, and it's ready to use in their project and ready to start generating maps. And so that's it. It's, like I said, very easy to install. If I now go back to my gem file, you'll see the addition of AppMap right here. It's, again, before the Rails gem, it's the first gem. That's where we want it. And you'll also see the creation of an AppMap configuration file. Where is it? Right here. And again, pretty simple configuration file, and this will help us generate our maps. So I'm going to go ahead and close this terminal since I'm done with that. And from here now, it's basically waiting for maps to be created. So we've got right here, there's no AppMaps in this project yet. There's a couple of ways to generate AppMaps, and we're going to show a couple of them here today. One of them is just running the application. So we ran it before with our bundle exec command. We're just going to rerun that command. And you'll see a new debug line getting spit out to the console, basically letting you know that remote recording and request recording is enabled. And what happens there is if I now open up my project and give it a refresh, I will get a AppMap presented to me into my code editor. Really just that simple. And this is showing what happens, what packages are used, what classes are being called, what functions within those classes are being called as part of a login API call, right? I refreshed the login page, and so that's where it took us. And we can then follow this code all the way down to the database, right? So what database queries are involved in just loading the login page? There are some of these queries here, and we can dive into them. So you get a couple of different views with your AppMap. This is the dependency view, being able to understand kind of what is dependent on what, the flow of the data that's happening in this view. And then we also have a trace view, which is probably closer to a stack trace type of view, where you can navigate through each of these different functions and classes, being able to see the data that we're sending around to each of these classes, the responses that are happening. And you'll even see these timers. This is all happening locally, but these timers are really helpful to understand different slow paths that might exist in the code base. So from here, that's one way to record our maps. The other way to record our maps is by running our tests. So same thing, I'm going to go back. I'm going to rerun the test suite again. And same scenario is going to happen is we'll get recording enabled by default for these tests. And you'll start to see these requests show up under a different collection. This is under the test section down here. And we'll get one AppMap for every test that executes. And so each of these will get streamed to us. We don't have to wait. We can actually start interacting with these if we want to while the tests are running, and be able to understand kind of what's happening as part of each of these tests. Now, again, these are all the tests that are related to not only the vulnerabilities that you can go fix, but also they have some other tests here that are just normal, make sure the functionality of the website doesn't break, which is why I'm actually running this larger set of tests. I just want kind of more maps to be able to show off for everyone here. So on the left-hand side, like I mentioned, we've got now maps from a variety of sources. We've got the requests. So for every API, which we'll actually do another test. I'll show you how to generate more of those requests kind of towards the end. And we'll have our spec tests as well. And so from here, we can kind of continue on through the onboarding, and we'll get taken to a page where we can start exploring some of these maps. If maybe we wanted to search for maps based on specific API calls. So I want to see anywhere that the dashboard home API call is part of, right? It'll take me to a list of maps that I could then open up each one of these and be able to understand kind of the path of code from API down to the database and back again. Same thing on the query side. We can see, different queries that maybe we care about more than others. Same thing. Those are all visible down in the code objects view. And if I wanted to see where I used certain queries, I could click into any of those. Same scenario. We'll get a whole list of every map that query was seen in. And then just some selected AppMaps, places maybe there's a lot of functions being used, a lot of SQL queries being called, and things like that. All righty. So from here, you'll also notice, let me drop this down, in our runtime analysis view, this is where AppMap, because we see this code execute, in our code editor here, we can now see the paths that the code is taking, and we can run our analyses on this code base to be able to understand what types of issues we're finding here. And there's a few different issues, some deprecated cryptographic algorithms that we might want to resolve. It'll take us to the specific lines where that is. And then there's this other one here, execution of untrusted system command, right? That does not sound particularly good. We might want to look into that. And this is the scenario that we're actually going to dive into today on not only finding this problem, but then fixing it and using AppMap to help you understand the impact of that fix, because any code change is going to change, how people interact with it. What's great is that when you do see these findings in AppMap, we do provide a link to the CWE page. So if you didn't really understand what this problem even is, maybe hadn't seen it before, you can learn some more information about that. And then it'll take you to the full stack trace as well. So this is where we can, again, learn more about this particular problem and dive into it, as well as the map as well. And so from here, I'm actually going to open a couple of things. We're going to go first to the stack trace. So this is the kind of relevant code where this issue is happening. I'm going to just clear a couple of these out of here. And you'll notice some AppMap pins that will exist on each of these functions. And this will be important later because we're going to show you what these pins really represent is we see this code, this function, we see this function being called in a map that you have. So what this is telling us is that this code is used in a particular place. It'll show us here not only that on this line here, the little squiggle is telling us here is where the problem is that this kernel system runs a untrusted command string. We can actually see it right here, right? Because we're just running a command. That's not necessarily good. If it's untrusted data, which it is, then an attacker could change this data to have it do whatever they want it to do and maybe take over the machine here. But then also it'll take us right to the AppMap itself. So I can go to this AppMap and it'll take us into this trace view where we're actually calling this data and what the data is. This was the data sent as part of the test, what this data is as part of this call. And then we can walk it back and see, okay, well, this is called by the silence streams function, which was called by make backup, which was called by benefits. And that's largely what we see in our code view. We can kind of walk our way back up, which is the save function calls make backup, and make backup takes that data and runs this command while calling the silent streams. And so that's where our issue kind of lies here. So now that we know where the issue is, we can go and fix this issue. So what I'm going to do is actually use a common tool in Ruby software engineering called Guard. And this is something that actually AppMap has some integration with so that I can run just the tests that are affected by this code change. So we ran all these tests. It took 30 seconds. Maybe you have a huge test suite and your test suite takes 30 minutes to run. If you make some changes to the code, you want to be able to run just the specific test that's affected by it. And that's something that AppMap can help with. So we're going to run Guard. And this is just going to kick us out and basically just say, hey, we're watching your project for any changes. And so from here, we're going to go and we're going to fix this issue. So I'm going to this is the problem. The problem is that we should just use standard libraries if we're going to copy files and not actually call a command specifically. So I'm going to just save this file. This has been saved now. And you'll notice over on the left-hand side, the AppMap that was created that this code runs inside of is now marked as out of date. And so this means that like we have changed this code. The map is no longer accurate to the most recent version of the code. But we can use that information to now run the test for this specific code path. And I can open the command palette. So this is actually this is a Command Shift P in VS Code. You can also open it via the menu bar at the top. The command palette's very powerful in VS Code. If you haven't spent much time with it, I highly recommend it because you can run a lot of helpful commands just directly from this command palette. And for this, we're going to run a command for AppMap, which is touching our out-of-date test files. And by doing that, you'll actually see down here the RSpec test running for just this particular AppMap. Now, in this test, I'm actually running it without any special environment variables because I want to run it in our training mode. Because what I want to do is I want this test to succeed if I have fixed the problem. And you'll see down here that instead of waiting 30 seconds for all the tests, I ran just the one test in 7 seconds. You can imagine with a larger test suite that saves quite a bit of time. And we have one example, no failures, right? So we have fixed this issue. And I think it even might kick out a past somewhere. And that's great, right? So we have fixed this issue. We can be done. But there is more that we can do with AppMap to understand kind of the impact. And we can also spend a little bit of time to show you how the pins have changed, right? So not only did this function now has no more pin, that means AppMap hasn't seen it. It doesn't see it in this code path. And it makes sense, right? Because we just removed the line that actually called that function. And if we now go back to this map again, and we open up this event, you'll see it looks a little bit different than before, right? Before we had benefit save and make backup and silent streams and everything else. Obviously we're not following that code path anymore. This map is now updated for the for the latest kind of code path from here, which is what if I want to diff the before and the after in a visual way. And so that's what we're going to do now. So I'm going to undo my code change back to here. And again, my test is now out of date because I've put that past, and I'm going to touch the out of date test file. So basically kind of set us back to where we were before. Let that test run. And then what I'm going to do with the updated map is I'm actually going to save this as a baseline. So this is a map that, again, this will fail. Perfect, right? That's what we want. And again, the finding has come back. The analysis has completed. And I'm going to save this map to a collection. And I've already created a collection called baseline, but these are just kind of functional ways to group your maps together. In kind of a grouping area like this. So I've got like I said, I got our baseline, and this is just a copy of the map. This is going to stay essentially unedited as we change our code. And so now I can go back and I'm going to implement this change again. But I'm actually going to simplify it even more, because as I look at this code, the save function is going to call make backup, which then just calls this other function with our command. And I can just simplify this entirely, which is what I'm going to do. So I'm going to comment out this line. I'm going to grab this, and just put it right here. And so I'm going to save this file. So yeah, I've got, like I said, I've got our code change here, and we're going to simplify entirely. We're going to basically cut out these two functions here, which means now both of these maps are going to be out of date, which makes sense because we made that change. So we'll go ahead and touch these test files again, which will rerun to update our maps. And you'll notice a little slight different change than last time, which is these pins will actually stick around. The map will update, and our test succeeds, but the pins will stay, and also the finding will stay. And that's basically because we still have a map in our local here where that code actually executes, and being able to go there. This function, for example, will actually exist in multiple maps, the baseline and the other one. But now we have a diff, right? We have an old version and a new version of that one. And so from here, I can go to my baseline and I can compare our sequence diagrams now to really any of the other maps. And now I can collect. So I've got at the top here, this is my baseline collection. I'll go to the RSpec test, and you could even do this on similar maps. Maybe they're not exactly the same code path, but they're close, and you want to understand the sequence difference between like user A interaction and user B interaction. But in this scenario, I'm just going to actually compare these two specific changes, right? And you'll see right down here is now we have, again, that same upload action happening, but instead of the make backup and silent streams functions getting used, these are now marked as deleted, and we still return back a string and a 302 message back to the user. The last area I wanted to talk about, which was OpenAPI documentation. And so this is kind of another example of how we can use this raw AppMap data in order to kind of inform other tools and give us additional ways of representing this data. And so for those that don't know, OpenAPI documentation, it's formerly known as Swagger Docs. This is a way of documenting your APIs to share with other people that might be interacting with your APIs, so they know how to kind of build for your APIs. And you can do it without having to share your code itself, because you can just share the definitions. And the definitions, so in this example, we've seen 63 different HTTP requests, based on the tests that we've run. So imagine a world where you have tests for all your APIs, which you hopefully should. You can now, with AppMap, capture that data and then export it into a format that is now exportable into other areas. So for example, you could actually import this data into Postman as a collection if you wanted to interact with specific endpoints. What we're actually going to do here is we're going to import this into Zap, OWASP Zap project, to be able to run a much more targeted and significantly quicker scan with Zap. So I'm going to just save this file locally. I'm actually going to save it into the public folder here, because I'm going to use Zap to just download that. So again, this could be a scenario where as you're running as you're updating your application, you can actually run AppMap even as part of your CI processes to essentially export this data out. And so keeping, again, your code and your documentation up to date along the way. So we've got this file saved in here. Now I can open up Zap. And this is actually up in the toolbar, so unfortunately you can't see it in my share, but there's an option to import an OpenAPI definition from a URL. And so I've got this data already on my URL. It's in my Rails app, but I just put it in the main folder. And same thing, target URL is going to be my Rails app. And so when I hit import, it's going to parse that data and go through and scan my site. And it will do it a lot faster than if you ran kind of an automated spider process where it will just try to go and explore all that data. And you get basically all of this data automatically loaded in. It's already in Zap. It's already flagged if there's any issues it found on the Zap side of things. If you have certain plugins that you kind of wanted to run as part of this, you get those notifications. But the last part that I want to share is that recording that we can do on the request side of things. Each of those each of those queries to these API endpoints now has its own map for each of those. So again, same thing. If I wanted to understand what happens as part of a specific API request, if I post to the users, what is the database query that's associated with that? Are there any runtime analysis that gets scanned as part of this? That all happens. And then on the same side, this is where this code will get instrumented with an AppMap pin. Again, same thing. You'll have these pins now get created so that you'll be able to see like this function. What maps is it in? Well, this is used in these specific maps. Or where is the account settings function being used? It's used in these maps. And if any of those maps are related to our requests, then those will also show up in the list as well for us to be able to kind of better understand, right? So this create command is part of the post users command. And that's that part of that user's controller there. And so again, this is where we can use tools, use essentially the output of this open data model, the AppMap open data model. We can use the output of this data to power some of our other applications and give us a little bit more insight into this data and use it to hopefully speed up some of the other things that we're doing, whether it's using, like I said, Zap to scan for for any externally facing vulnerabilities or anything like that.